Hi guys, welcome back to another video. Today we're going to be looking at the following math counts problem that tests our knowledge of areas of simple plane figures. And as always, let's start with a read. So ABCD is a trapezoid with parallel bases of AB equal to 8 and CD equal to 14. Let's just draw that in right away. Point M is the intersection of the diagonals of trapezoid ABCD, and points E and F lie on base CD to form parallelograms ABCF and ABED. And they tell you the area of trapezoid ABEF is 60, and we want to find the area of ADM, right? Okay, so let's start with some of the easy things. So we know that we have two parallelograms right here, these ones, ABCF, let's draw that better. So we have ABCF and we have ABED. Right, so if we look at ABCF, we would see that if AB is 8, which is given to us, that means CF is also 8. Right, so this distance is 8. And similarly, ABED is a parallelogram, which means that AB and ED are both 8 as well. So that means if we know CF and ED are both 8, and we know CD is 14, right, I could bring it here. I know this whole thing is 14. I know this distance right here is 8, and I know this distance here is 8. That means that this middle piece is 2, and these are each 6, because the whole thing adds to 14. Right, so we could remove all of this and just write CE is 6, EF is 2, FD is 6. Okay, so that basically takes care of this line right here. We've used that information now. Now, they also tell us the area of trapezoid ABEF. So ABEF, the area of this trapezoid, is 60, right? ABEF, we see that the bases are 2 and 8. And so if you recall, the area of a trapezoid is just the average of your bases times your height, right? I know the value of both my bases. That's half of 2 plus 8 times my height, and that's equal to 60. So that means 60 is equal to 5h. So h, which is the height of the trapezoid, is 12. So that means, going back to this problem, the height of ABEF is 12, and that coincidentally means the height of ABCD is also 12, right? Because they're the same, they have the same bases. Okay, so that's good. Now we have the height. And now we're pretty close to being able to solve for AMD, right? That's this triangle right here. We want to find the area of this. Now, clearly, we can't really find the base or the height of this triangle, right? Like you could say AM is your base, but then it's pretty hard to find the height. And you just see that none of the heights are really easy to find. So we approach this using similar triangles, right? Because when you have parallel lines, that means you have tons of similar triangles. And so the idea here is that if we get rid of the shading, ABM, triangle ABM, is going to be similar to triangle CDM, right? And you could see this because this angle right here is going to be equal to this angle due to alternate interior angles. And similarly, if we do a different color, say purple, this color or this angle right here is equal to this angle. And that's enough to tell us by angle-angle similarity that the two triangles are similar, right? And so now what that does for us is it lets us write out the ratios from AM to MC, right? Because AM, so we have, let's switch this. AM, we have AM over AB, right? AM over AB would equal CM over CD using our similar triangles statement up here. And now what I could do here is I know AB and CD, right? We know that this is just means AB or AM over 8 equals CM over 14, right? Because AB is 8, CD is 14. So 14 AM equals 8 CM, right? And I could divide by 2. 7 AM equals 4 CM. So this means the ratio of AM to CM is 4 to 7, right? So if I call this, say, 4x, and CM is 7x, right? That helps us now because if we look at triangle ADC, right? Triangle ADC, that we can find the area of. Let's do that real quick. The area of triangle ADC, this is base times height, so half base height, right? Our base is CD, which we know is 14. Half, and we found our height is 12, right? This 12 right here, that the height of the trapezoid is also the height of that triangle. So we have half of 14 times 12, and that is just 84. So the area of triangle ADC is 84. Now, if I look at triangles, here, let's bring them back here, AMD, right? Let's color these just so we could see them. If I look at triangles AMD, that's this triangle right here, right? What we want to find. And this triangle right here, CMD. These two areas, the blue plus the purple, has to add up to our total ADC, which we found 84. And also, we know the heights of these triangles with respect to AC is the same, right? The height is basically just this value right here. But we know the bases have a ratio of 4 to 7, right? So that means that the area of the triangles also have a ratio of 4 to 7 because your bases are 4 to 7 and your heights are the same. So what that means is, if we were to bring this back here, the area of AMD, so the area of AMD is just 4 over 4 plus 7, right? If it's 4 to 7, that means the area of AMD to the whole triangle ACD is 4 to 11. So 4 over 4 plus 7 times 84, right? And this is just 4/11ths of 84, and that is 336 over 11. And that is actually our final answer, right? And let's just check the problem, make sure we're answering the question. They ask us for the area of trapezoid, or the area of triangle ADM as a common fraction. We found that to be 336 over 11, and we are done. So that should be all for the question today. If you have any questions on how we solve this, please leave a comment. And if you found the video helpful, like and subscribe really helps us out. But that should conclude today's video, and I will be back again tomorrow with another problem of the day. Thanks to everyone for joining.